NENOMATICA, where mathematics meets YouTube excellence. Welcome to this math video where we'll solve a cubic equation using factoring. Some special cubic equations can be solved through factoring and grouping techniques. Let's look at our example. We need to find the roots of the cubic equation x cubed minus 3x squared minus 4x plus 12 equals 0. We'll solve this equation step by step using factoring techniques. First, let's rewrite this equation in a form that helps us see a potential factorization. Let's try to rewrite our equation in a more useful form. We'll rewrite this as open parenthesis x cubed minus 3x squared close parenthesis minus 4 times open parenthesis x minus 3 close parenthesis equals 0. For our next step, we notice that we can factor out x squared from the first parenthesis. This gives us x squared times open parenthesis x minus 3 close parenthesis minus 4 times open parenthesis x minus 3 close parenthesis equals 0. Now we can see that both terms have a common factor of x minus 3. So we can factor this out to get open parenthesis x minus 3 close parenthesis times open parenthesis x squared minus 4 close parenthesis equals 0. We can further factor x squared minus 4 as the difference of squares. So our equation becomes open parenthesis x minus 3 close parenthesis times open parenthesis x plus 2 close parenthesis times open parenthesis x minus 2 close parenthesis equals 0. Now we can solve for the roots of our equation. Since we have a product equal to 0, at least one of the factors must be 0. So we have x minus 3 equals 0, which gives us x equals 3. Or x plus 2 equals 0, which gives us x equals negative 2. Or x minus 2 equals 0, which gives us x equals positive 2. Therefore, the roots of our cubic equation are x equals 3, x equals 2, and x equals 2, and x equals negative 2. Let's quickly verify that these values are indeed the roots of our original equation. If we substitute these values back into the original equation, x cubed minus 3x squared minus 4x plus 12 equals 0, we should get 0 for each value. To summarize what we've learned, we solved a cubic equation by factoring and grouping. First, we rewrote the equation to help with factoring. Then we factored out common terms step by step. We used the difference of squares formula to further factor our expression. Finally, we used the zero product property to find the three roots x equals 3, x equals negative 2, and x equals 2. This method works particularly well for certain cubic equations that can be factored completely. Here's a quick challenge for you. Try to solve the cubic equation x cubed minus 6x squared plus 11x minus 6 equals 0 using the same method. Pause the video and give it a try. You should find that the roots are x equals 1, x equals 2, and x equals 3. Let's solve the cubic equation x cubed minus 2x squared plus 2x minus 4 equals 0. Let's start by grouping the terms. We can rewrite this as open parenthesis x cubed minus 2x squared close parenthesis plus open parenthesis 2x minus 4 close parenthesis equals 0. Next, we'll factor out common terms from each group. From the first group, we can factor out x squared to get x squared times open parenthesis x minus 2 close parenthesis. From the second group, we can factor out 2 to get 2 times open parenthesis x minus 2 close parenthesis. Now we notice that both terms have a common factor of x minus 2. We can factor this out to get open parenthesis x minus 2 close parenthesis times open parenthesis x squared plus 2 close parenthesis equals 0. When a product equals 0, at least one of the factors must be 0. So we have two cases, either x minus 2 equals 0 or x squared plus 2 equals 0. Let's solve each equation. For the first case, x minus 2 equals 0. We add 2 to both sides to get x equals 2. For the second case, x squared plus 2 equals 0. We subtract 2 from both sides to get x squared equals negative 2. Taking the square root of both sides, we get x equals plus or minus the square root of negative 2, which are complex numbers. Let's summarize our findings. We found that the cubic equation x cubed minus 2x squared plus 2x minus 4 equals 0 has one real root at x equals 2 and two complex roots at x equals plus or minus the square root of negative 2. Since x squared plus 2 doesn't have any real roots, we can say that the equation x squared plus 2 equals 0 has no real roots. Today, we'll solve a cubic equation using factoring methods. Let's look at our example. Let's start by writing our equation in standard form. We already have the equation x cubed plus 4x squared minus 5 equals 0, so we're ready to proceed with the solution. Next, let's group some terms to begin the factorization process. We'll factor the equation as x squared times the quantity x minus x plus 5x squared minus 5 equals 0. Notice I've rewritten the first two terms as x squared times open parenthesis x minus x close parenthesis. I've added and subtracted x squared, which doesn't change the equation's value. Now we can factor out x squared from the first group of terms. So we have x squared times open parenthesis x minus 1 close parenthesis plus 5 times open parenthesis x squared minus 1 close parenthesis equals 0. We can factor x squared minus 1 as open parenthesis x minus 1 close parenthesis times open parenthesis x plus 1 close parenthesis. So our equation becomes x squared times open parenthesis x minus 1 close parenthesis plus 5 times open parenthesis x minus 1 close parenthesis times open parenthesis x plus 1 close parenthesis equals 0. Now we can see that open parenthesis x minus 1 close parenthesis is a common factor in both terms. So we can factor it out. We get open parenthesis x minus 1 close parenthesis times open bracket x squared plus 5 times open parenthesis x plus 1 close parenthesis close bracket equals 0. Now, let's expand the expression inside the square brackets. We have x squared plus 5x plus 5. So our equation becomes open parenthesis x minus 1 close parenthesis times open parenthesis x squared plus 5x plus 5 close parenthesis equals 0. According to the zero product property, if a product equals 0, then at least one of the factors must be 0. So either x minus 1 equals 0, or x squared plus 5x plus 5 equals 0. From the first equation, we get x equals 1. For the second equation, we need to use the quadratic formula. For the quadratic equation, we use the formula x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. In our case, a equals 1, b equals 5, and c equals 5. So x equals negative 5 plus or minus the square root of 25 minus 20, all divided by 2. This simplifies to x equals negative 5 plus or minus the square root of 5, all divided by 2. So the solutions to our cubic equation are x equals 1, x equals negative 5 plus the square root of 5, all divided by 2, and x equals negative 5 minus the square root of 5, all divided by 2. Let's simplify the last two solutions further. The second solution is approximately negative 5 plus 2.24, all divided by 2, which is approximately negative 1.38. The third solution is approximately negative 5 minus 2.24, all divided by 2, which is approximately negative 3.62. Let's summarize what we've learned about solving cubic equations by factoring. First, we need to write the equation in standard form with 0 on one side. Next, we look for ways to group terms and factor out common expressions. Then, we apply algebraic identities like the difference of squares to further simplify. Finally, we use the zero product property to find all solutions. This method works well when at least one root can be found by inspection or factoring. For future study, let's look at our problem. We need to find the roots of the following cubic equation: 4n cubed plus 6n squared plus 4, n plus 1 equals 0. Following the given solution method, our first step is to multiply both sides of the equation by 2. When we multiply each term by 2, we get 8n cubed plus 12n squared plus 8n plus 2 equals 0. Now, following our solution method, we express this in terms of 2n. We can write this as open parenthesis 2n close parenthesis cubed plus open parenthesis 2n close parenthesis squared times 3 plus open parenthesis 2n close parenthesis times 4 plus 2 equals 0. Let's substitute x equals 2n to simplify our work. This gives us x cubed plus 3x squared plus 4x plus 2 equals 0. Next, we'll rearrange the terms to group them in a way that will help with factoring. We can rewrite our equation as x cubed plus 3x squared plus 4x plus 2 equals 0. Now we'll start grouping terms x cubed plus open parenthesis x squared plus 2x squared close parenthesis plus open parenthesis 2x plus 2x close parenthesis plus 2 equals 0. Now we continue with our regrouping. We can rewrite this as x cubed plus x squared plus 2x squared plus 2x plus 2x plus 2 equals 0. Now we'll further organize by factoring out common terms x squared times open parenthesis x plus 1 close parenthesis plus 2x times open parenthesis x plus 1 close parenthesis plus 2 times open parenthesis x plus 1 close parenthesis equals 0. Looking at our expression, we can see that open parenthesis x plus 1 close parenthesis is a common factor in all terms. Let's factor it out. Open parenthesis x plus 1 close parenthesis times open parenthesis x squared plus 2x plus 2 close parenthesis equals 0. By the zero product property, if a product equals 0, then at least one of the factors must be 0. So either x plus 1 equals 0, or x squared plus 2x plus 2 equals 0. From the first equation, x equals -1. For the second equation, x squared plus 2x plus 2 equals 0. We need to determine if it has real solutions. To determine if the second equation has real solutions, we'll complete the square. For the equation x squared plus 2x plus 2 equals 0, we can rewrite it as x squared plus 2x plus 1 equals 0. This gives us open parenthesis x plus 1 close parenthesis squared plus 1 equals 0. Solving this equation, open parenthesis x plus 1 close parenthesis squared equals -1. Since the square of a real number cannot be negative, this equation has no real solutions. Now that we found x equals -1 as our only real solution, we need to convert back to our original variable n. Remember that we substituted x equals 2n, so 2n equals -1, which means n equals -1/2. Let's verify our answer by substituting back into the original equation. For n cubed plus 6, n squared plus 4, n plus 1, with n equals -1/2. Let's calculate 4 times -1/2 cubed plus 6 times -1/2 squared plus 4 times -1/2 plus 1. Simplifying, 4 times -1/8 plus 6 times 1/4 plus 4 times -1/2 plus 1. This equals -1/2 plus 6/4 plus -2 plus 1, which equals -1/2 plus 3/2 minus 2 plus 1. This simplifies to 0, confirming our solution. Therefore, the only real solution to our original cubic equation 4n cubed plus 6n squared plus 4n plus 1 equals 0 is n equals -1/2. In summary, we solve this cubic equation by 1. Multiplying both sides by 2, substituting x equals 2n to simplify 3, factoring the resulting equation 4, using the zero product property 5, converting back to our original variable 6, verifying our solution. Let's look at our equation x cubed minus x squared minus 4 equals 0. Let's start solving this equation. Step 1. We'll rewrite the constant term. We want to recognize a pattern that will help us factor this expression. Let's try subtracting and adding 8, which will help us create a difference of cubes. So we have x cubed minus x squared minus 4 equals 0. We can rewrite this as x cubed minus 8 minus the quantity x squared minus 4 equals 0. Quick challenge. Can you figure out why we chose to add and subtract 8 specifically? Take a moment to think about it. Great. The reason we chose 8 is because it's 2 cubed, which will help us create a difference of cubes pattern. And the 4 is 2 squared, which will create a difference of squares pattern. Step 2. Let's factor each part of our expression. First, we recognize that 8 is 2 cubed. Also, x squared minus 4 can be factored as a difference of squares. X squared minus 4 equals x minus 2 times x plus 2. So our equation becomes x cubed minus 2 cubed minus the quantity x minus 2 times x plus 2 equals 0. Now we're ready for the next step. Step 3. Let's apply the difference of cubes formula to the first term. The difference of cubes formula states that a cubed minus b cubed equals a minus b times the quantity a squared plus a times b plus b squared. In our case, a is x and b is 2. So x cubed minus 2 cubed becomes the factor x minus 2 times the quantity x squared plus 2x plus 4. Now our equation is x minus 2 times x squared plus 2x plus 4. minus the quantity x minus 2 times x plus 2 equals 0. Notice something important here. Both terms now share a common factor of x minus 2. Great progress! Step 4. Let's factor out the common term x minus 2. We can use the distributive property in reverse to factor out x minus 2. We get x minus 2 times the quantity x squared plus 2x plus 4 minus the quantity x plus 2 equals 0. Now we need to simplify the expression inside the brackets. Step 5. Let's simplify what's inside the bracket. We'll distribute and combine like terms inside the brackets. We have x squared plus 2x plus 4 minus x minus 2. Combining like terms, we get x squared plus x plus 2. So our equation is now x minus 2 times x squared plus x plus 2 equals 0. We're almost done. Step 6. Now we can set each factor equal to 0 to find the solutions. When a product equals 0, at least one of the factors must be 0. Quick challenge. What are the roots of this equation? Can you determine if x squared plus x plus 2 has any real roots? For the first factor, we have x minus 2 equals 0, which gives us x equals 2. For the second factor, x squared plus x plus 2 equals 0. Let's check if it has real roots. To check for real roots, we calculate the discriminant, b squared minus 4ac. Here it equals 1, b equals 1, and c equals 2. So the discriminant is 1 squared minus 4 times 1 times 2, which equals 1 minus 8, which is negative 7. Since the discriminant is negative, the quadratic equation x squared plus x plus 2 equals 0 has no real roots. Therefore, the only real solution to our original equation x cubed minus x squared minus 4 equals 0 is x equals 2. Let's summarize what we've learned. First, we rewrote the equation to expose a difference of cubes. Then, we factored using the difference of cubes formula. A cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Next, we factored out common terms. Finally, we solved each factor equation to find the real roots. This process can be applied to many cubic equations, especially those that can be rewritten in a form that allows us to use factoring techniques. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.